Howdy. Today we're going to do an experiment with a little bit of Clorox and a little bit of green food color. Let me first get my safety goggles. Here we go. Alright, so this is very simple, where we are simply going to take our food coloring, and your lab procedure says to use 100 milliliters of water and 10 milliliters of chlorine bleach. Now that is a little too slow with this food coloring, so we are going to double the volume of bleach. However, we need to keep the volume of the experiment constant, so total we had 110 milliliters, 100 water, 100 of bleach. So we're going to use 90 of water and then 20 of the bleach. So we'll double the volume of the Clorox, double the amount of, double that. So here we go. We are let me use my graduated cylinder. And so there is 90 milliliters of water. And then we'll take 1 drop of green food coloring. This is the gel food coloring, so it is going to be really thick. And we'll go ahead and stir it up, and you'll see that it's very, very green. Gotta get all that gel dissolved. And there we go. So now, to do this, the color is going to change. So what we'll use a colorimeter, like I've shown you before. And remember, I've done all the important steps of letting it warm up, and I have also taken a clean cuvette full of deionized water. I place it in there, and I'm setting it to 635 nanometers of my absorbance. It's going to absorb 635 nanometers. So then I will calibrate it, make sure that's okay, and then I'm going to let it go. Now, what is going to happen is once I pour the bleach in there, the reaction will start. I will then immediately take this out, pipette some into a clean cuvette, place it in here, and then start my experiment. So you may be wondering, in all of our classroom stuff, we've been thinking about concentration versus time. Well, in this one, we are going to measure absorbance versus time. Well, if you remember that the absorbance is directly proportional to the concentration, and it's related by the path length of the cuvette, and it's also related by the molar absorptivity of the sample. So assuming that the molar absorptivity and that the path length remain the same, the concentration and the absorbance will still have the same relationship. So the absorbance will be on the y-axis, even though typically in our classroom setting, concentration is on the y-axis. So let's get ready to do this. I will pour 20 milliliters of Clorox into here. And then once we begin, I will quickly move it over. So just as you can see, it changed color to a blue color. And then now I'm going to pipette it very closely, very carefully, because I do not want that many bubbles. The turbidity of the sample does matter. You want to make it a very clear sample. Go as quick as I can. And we're done. The data I'm going to give you is simply just a stopwatch and the absorbance. So it is up to you to collect your own data, and you need to, it's over a period of 20 minutes. So you could go by every 10 seconds, you could go by, and you should probably go by every 10 seconds. And then take an absorbance reading in a spreadsheet, and then you'll highlight all of that data. That's going to be a lot, I know, and then use an Excel spreadsheet or a Google Sheet spreadsheet to create a graph for you. And then once you find the trend line of that graph, that will show you your equation. Now, you're not necessarily interested in the equation. What you were looking at is the shape of that graph. If it is, you're going to plot the graph either as the concentration over time or the natural log of concentration over time, and you're going to plot the reciprocal, the 1 over concentration over time versus time. That's the way it's going to work. And so you'll have 3 different graphs. Now, whichever the one is the most linear is going to show you which order the reaction is. So if it is concentration versus time, if that is linear, then it is a 0 order reaction. For the natural log of the concentration versus the time, that would be a first order reaction. And then if for the reciprocal, for the 1 over concentration versus time, that would be a second order reaction if that one is linear. Hopefully that makes sense to you, and you will be able to complete that. Hopefully that made sense. Let me know if you have any questions. Bye.